Plasma thread materials represent one of the most breathtaking frontiers in future material science. A concept that fuses the raw energy of plasma with the structural stability of matter to create fabrics stronger than titanium, lighter than air, and capable of dynamically interacting with their environment. Imagine a thread made not of traditional fibers or polymers, but of captured plasma, stabilized and woven into strands that conduct energy, shift form, and even heal themselves. In a world driven by ever-increasing technological demands, plasma thread materials may redefine how we build, wear, and power the future. To understand the idea of plasma thread materials, let's start with the basics. Plasma is often called the fourth state of matter. It's what stars are made of, a swirling soup of ions and free electrons moving at incredible speeds. On Earth, we see plasma in lightning, neon lights, and fusion reactors. It's high energy, volatile, and difficult to contain. But imagine if you could stabilize plasma long enough to manipulate it, not in giant fusion chambers, but on the microscopic level. What if plasma could be spun into fibers, each strand containing controlled energy fields that give it extraordinary properties? That's the theoretical foundation of plasma thread materials. Scientists envision threads made from plasma confined within magnetic or electromagnetic sheaths. These sheaths could act like invisible containers, keeping the plasma stable while allowing it to remain flexible. Each thread would be a living conduit of energy, able to store charge, emit light, resist extreme heat, and even interact with digital systems through electromagnetic resonance. Instead of static materials, these threads could behave almost like programmable matter, responsive, dynamic, and intelligent. Creating such a material, however, is no small task. The main challenge lies in confinement. Plasma, by nature, wants to expand and dissipate. In fusion research, magnetic fields are used to contain it, but those systems are enormous and consume vast amounts of power. Miniaturizing that confinement into microscopic threads requires breakthroughs in magnetic field control, nanostructuring, and materials that can sustain immense energy flux. Researchers have proposed the use of superconducting nanocoils that could generate localized magnetic cages around plasma filaments. These coils, arranged in ultra-fine arrays, would essentially trap plasma into linear forms, threads of pure, luminous energy woven through an electromagnetic lattice. If that sounds like science fiction, you're right, but it's also science in progress. In recent years, experiments with plasma filaments and plasma metamaterials have shown intriguing results. Some research teams have managed to maintain stable plasma channels for milliseconds longer than previously thought possible, using layered magnetic feedback loops. Others have experimented with plasma-based coatings that self-heal or conduct signals faster than metallic wires. Extrapolate those advances, and plasma thread fabrics become not only plausible but inevitable within the next century. The potential applications are staggering. Imagine clothing that adapts to temperature by modulating its plasma field, becoming warmer or cooler on demand. Or armor that redirects incoming energy, laser, heat, or kinetic impact, by dispersing it across a plasma lattice. Plasma thread buildings could withstand fire, radiation, or even reconfigure their surfaces for camouflage. In aerospace engineering, plasma thread composites could lead to spacecraft hulls that regenerate minor damage or create electromagnetic shields against micrometeorites and cosmic rays. Now consider the realm of energy. Plasma thread cables could transmit power wirelessly across vast distances. Each thread would act as a stabilized current channel, far surpassing copper or graphene in conductivity. Imagine a city grid where energy flows invisibly through walls, fabrics, and air, all interconnected through plasma thread infrastructure. The implications extend beyond engineering, into how civilization itself might evolve. In architecture, plasma thread materials could redefine construction. Picture skyscrapers built not from steel and glass but from plasma thread composites that can shift transparency, absorb sunlight, and self-regulate internal temperature. The buildings themselves could become power plants, converting atmospheric ions into usable energy. In transportation, vehicles could be lined with plasma thread membranes that actively respond to drag forces, dynamically altering their shape mid-flight. Even in medicine, the uses are profound. Plasma thread sutures could sterilize themselves during surgery, fuse tissue faster, and dissolve once healing is complete. Implantable meshes woven from plasma threads could interface directly with the nervous system, allowing prosthetics or artificial organs to function seamlessly. In robotics, these threads could become the tendons and muscles of next-generation androids, soft, luminous, and capable of instant adaptation. To truly grasp the beauty of this idea, think of plasma thread materials as the intersection between light and matter. They are both physical and energetic, tangible yet alive with potential. Each thread carries the energy of a miniature sun, disciplined by human ingenuity into order and structure. It's a triumph of control, turning chaos into creation. Of course, the ethical and environmental questions will emerge quickly. Stabilizing plasma requires enormous energy, and mismanagement could result in dangerous discharges or radiation leakage. Production of these materials might need entirely new forms of containment infrastructure, miniature fusion-grade facilities. There will also be geopolitical implications. Whoever controls plasma thread technology could dominate not just industry, but energy distribution and defense systems worldwide. Plasma thread armor, for instance, could render conventional weapons obsolete. Plasma thread data systems could make information transfer almost instantaneous, leading to communication monopolies. The societal effects would ripple outward. Plasma thread fashion could become the next luxury symbol, garments that glow, shift color, and project digital imagery. These clothes might become living expressions of personality, evolving in real time. But like all high-end tech, it could widen inequality until replication methods become accessible. Over time, though, as production scales and automation improves, plasma thread materials could democratize. Eventually, every home, every car, every wearable might integrate plasma thread networks that connect directly to personal AI systems. Your shirt could act as your computer. Your walls could serve as data processors. The environmental potential, on the other hand, could be extraordinary. Plasma thread air filters could ionize pollutants, neutralize viruses, and generate clean air at massive scales. Woven plasma nets could protect cities from harmful radiation or serve as gigantic energy harvesters in orbit, collecting solar plasma from space storms and converting it to usable electricity. Humanity could move toward an era where energy and matter merge seamlessly, a symbiosis between civilization and plasma itself. Plasma thread technology might also merge with quantum and photonic science. Quantum plasma threads could store quantum states, enabling quantum communication across vast distances. Photonic plasma threads could emit tunable wavelengths, turning any surface into a programmable holographic display. The lines between textile, circuit, and organism would blur completely. Your clothing could display news updates, translate speech in real time, or sense danger through electromagnetic changes. In the defense sector, plasma thread materials could revolutionize armor and shielding. Instead of heavy metallic plating, future soldiers or spacecraft could use dynamic plasma thread fields that deflect projectiles and absorb energy bursts. These threads could even reconfigure themselves when detecting certain frequencies, creating real-time protection against directed energy weapons. A fleet of ships coated with plasma thread composites could become invisible to radar or reroute incoming energy weapons through adaptive plasma diffusion. The age of static defense would end, replaced by intelligent, reactive material systems. Imagine a bridge woven from plasma thread cables. It glows faintly at night, self-repairing microfractures as they form. The structure monitors its own integrity, adjusting tension when sensors detect seismic activity. It even harvests ambient electricity from the surrounding atmosphere, feeding the local grid. This is not merely science fiction. It's a blueprint for self-sustaining, self-aware infrastructure. To achieve this vision, humanity will need to merge expertise from multiple fields: plasma physics, nanotechnology, photonics, electromagnetism, and AI-based control systems. We'll need to develop self-regulating confinement algorithms that balance plasma stability with minimal energy draw. Advanced superconductors, perhaps room temperature ones, will be crucial for maintaining containment without waste heat. Once that threshold is crossed, plasma thread production could scale exponentially. We might see plasma thread looms, machines that weave magnetic fields instead of yarn. Each loom could produce kilometers of living fiber, its glow faintly visible as it cools from formation. Scientists may design new plasma recipes, each with unique color signatures and behaviors. One thread might shift hue depending on emotional input from the wearer. Another might stiffen or relax depending on gravitational pressure. Plasma thread materials wouldn't just replace conventional fabrics, they'd transcend the concept of material altogether. The artistic implications are just as rich. Architects could sculpt with energy. Designers could weave light itself. Imagine cathedrals of plasma glass, sculptures that float in magnetic suspension, art installations that hum softly as plasma flows through their veins. Human creativity would finally meet its elemental equal: the living fire of the universe, harnessed and woven into form. But behind the beauty lies responsibility. Plasma is the most abundant state of matter in the universe, yet the most untamed. Mastering it will mean wielding near divine control over energy. Just as humanity once learned to control fire, and later electricity, the control of plasma on a microscopic level could define a new era of civilization, the Plasma Age. In this age, power generation, communication, and construction could converge into one universal system, all built from threads of controlled energy. The economics of plasma thread technology would reshape global industries. Textile manufacturing would no longer depend on cotton, silk, or synthetics, but on plasma containment. Mining for rare metals might decline, replaced by harvesting atmospheric elements for ionization. Energy companies might shift focus from production to stabilization, selling plasma thread containment grids instead of fuel. Developing nations could leapfrog industrial stages, building infrastructure made of clean, durable, and self-sustaining materials. This technology would also redefine identity. Just as we once used clothing to express culture, plasma thread fashion could become an expression of state of being. Individuals could tune their clothing to match mood, environment, or even health status. Medical sensors embedded in the fabric could alert emergency services automatically. Plasma thread homes could sync with biological rhythms, adjusting lighting and temperature to enhance well-being. The integration between human biology and plasma thread systems could lead to something profound: a civilization where every object, every structure, every environment interacts consciously with its inhabitants. From a cosmic perspective, plasma thread materials could even play a role in interstellar colonization. Ships built from plasma thread composites could generate their own magnetic shielding, protect crews from radiation, and even manipulate surrounding space plasma for propulsion. Colonies on Mars or Titan could use plasma thread domes to create breathable atmospheres and regulate temperature extremes. Humanity's expansion into space might depend on how well we learn to weave with light. In essence, plasma thread materials represent the synthesis of nature's most volatile force with humankind's highest craftsmanship. They are the future fabric of civilization, literally and metaphorically. Just as cloth once marked the beginning of culture and identity, plasma thread textiles could mark the next leap in human evolution. From creatures who wear matter to beings who wear energy itself. The story of plasma thread materials isn't just about new technology, it's about control, creativity, and destiny. It's about how far we can go when we decide to weave the universe's most powerful element into the fabric of our lives. Someday soon, our world may glow softly. Not from artificial lights, but from the plasma thread we've stitched into everything around us. And when that day comes, humanity will have truly learned to wear the light of the stars. Hey everyone! If you enjoyed this video, make sure to hit that like button, drop a comment to share your thoughts, and subscribe so you don't miss any of our future uploads. Your support helps this channel grow. Thank you for watching.